For millennia, oral traditions populated the world with terrifying figures, passing down warnings of towering giants, one-eyed cyclopes, ravenous wolfmen, and infant changelings. Many modern interpretations assume these myths grew solely from superstition. We often view ancient societies as simple observers, creating these creatures out of a primal fear of the dark and the unknown. These early cultures lacked our modern vocabulary of DNA replication or teratogens, environmental factors that cause congenital malformations. In place of molecular science, they used myth to meticulously record extraordinary, real-world human biological variations. Because ancient societies recorded medical anomalies as terrifying stories, modern audiences often assume the real people born with these traits were treated as monsters. This creates a severe distortion of our own history. Seeing the historical reality requires us to look past the supernatural narrative. By stripping away the layers of folklore, we find a biological truth that has been hidden for millennia. Precision medicine and whole genome sequencing allow us to look backward. By understanding the microscopic mechanics of development, geneticists can now retroactively diagnose the physical traits that inspired history's most enduring legends. The werewolf legend maps closely to hypertrichosis, an exceedingly rare congenital condition characterized by thick hair growth over the entire body. In communities lacking genetic literacy, a child born with this spontaneous mutation provided the tangible framework for the myth of the lycanthrope. Legends of giants, from the biblical Goliath to the indigenous Zunukwa, follow a similar pattern. Endocrine tumors on the pituitary gland drive unregulated, excessive bone and tissue growth. This results in extreme height and heavy craniofacial features, precisely matching the phenotypic descriptions found in folklore. The Cyclops myth likely merged biology with paleontology. Mediterranean islands are filled with the fossilized skulls of dwarf elephants, which feature a massive central nasal cavity. Ancient Greeks, having never seen a living elephant, identified this central void as a single giant eye socket. This fossil evidence found a living reference point in allobar holoprosencephaly. In this severe developmental arrest, the embryonic forebrain fails to divide, occasionally creating a singular midline eye that mirrored the descriptions of Homer's Polyphemus. Monsters were the direct result of ancient societies encountering extreme edges of human biological variation. The European changeling myth, the belief that fairies swapped a human infant for a shriveled troll, stems from the reality of sudden developmental regressions. These substitutions explain congenital disorders that only became apparent months after birth. Hutchinson-Gilford progeria syndrome causes rapid premature aging due to a mutation in the LMNA gene. An infant with this condition develops a prominent scalp, a beaked nose, and wrinkled skin, providing a visual match for the changeling of Celtic tradition. However, modern science is also capable of dangerous mythologizing. In the 1980s, researchers proposed that the blood disorder porphyria inspired the vampire myth. Modern medical historians have since definitively debunked this, noting that porphyria is simply too rare to account for systemic vampire panics. Falsely linking genetic patients to undead monsters causes genuine psychological harm today. Interpreting folklore requires an uncompromising commitment to historical and scientific accuracy. While texts provide the narrative, paleopathology provides the proof. Scientists bypass the biases of mythological records by reading the health and life history recorded directly in ancient skeletal remains. Bioarchaeological data reveals what we call the empathy paradox. Skeletal evidence, including bone density analysis and the presence of healed lesions, demonstrates that individuals with severe physical differences were often granted systemic care and social integration. In Chaco Canyon, ancestral Puebloans with 6 toes were not feared. Bioarchaeological finds, including specialized sandals designed for extra digits, prove that polydactyly was actually a marker of high social status. Ancient Egyptian society elevated individuals with achondroplasia to the highest echelons of power. Senep, a royal official during the 4th dynasty, was buried in a lavish tomb. His family statue portrays his short stature with the same dignity and respect as his average-statured wife. Surviving into adulthood with a severe congenital condition in the ancient world required immense, sustained communal support. The archaeological record shows that this care was a consistent part of many early societies. In 2024, researchers identified Tina, a Neanderthal child from 146,000 years ago who lived with Down syndrome. Micro-CT scans of her inner ear confirmed that she would have suffered from severe deafness and vertigo. Tina survived to at least 6 years of age. This duration of survival in a hunter-gatherer context proves her community provided continuous, altruistic care. This discovery challenges the assumption that early human groups lacked compassion for their most vulnerable members. This table highlights how the same genetic conditions appeared across vastly different ancient cultures, from Egypt to the Americas. Faced with the extraordinary extremes of human biology, the brain's pattern recognition engine created these myths to try and restore a sense of order and meaning. These spontaneous mutations are the essential mechanism of human evolution. Without this capacity for genetic variation, our species would lack the diversity that drives adaptability. Ancient societies enshrined these physical differences in myth, recognizing the profound biological power they witnessed firsthand. The biological reality behind these legends is now clear. The archaeological record, from the burial of a disabled Neanderthal child to the exalted status of achondroplastic officials in Egypt, reveals that even our earliest ancestors often responded to human difference with sustained communal care.